Hello, I'm Dr. Tina Cannon from Chuniga State, and in this video segment we're going to be discussing how to use the TI calculator to find probability with standard normal distributions and normal distributions, and then we're going to take a probability and find a z-score. So in this, what we want to do is use some handouts that are located in your course under Calculator Instruction. This is Unit 3, and we want to first use the one that says Standard Normal Distribution. And in this particular problem, when we're dealing with a standard normal distribution, what this means is the standard deviation will be 1 and the mean will be 0. That is considered a standard normal distribution. And what happens is the middle of our graph, this will be a bell-shaped curve, the middle will be 0. And then each mark represents one standard deviation above and below the mean. Now in this particular problem, it says assume that the readings on thermometers are normally distributed with a mean of 0 and a standard deviation of 1 degree. Find the indicated probability where z is greater than 1.645. And the mark that we have in our graph, the beginning mark will be the z-score, which is 1.645, and notice it says they want to find the probability that it's greater, so the shading is to the right. This is very important to draw your graph so that you can tell what to put into the calculator and to understand where the shaded area is located. That area corresponds to your probability. So this is a drawing that we have. Now, what we want to do is find the area. So we're going to, if you look, you can see the steps of this, but we're going to call up the calculator. And under second and variables, notice it says distribution. We're dealing with a standard normal distribution, so that's the key that we want to use. So we're going to push second and vars for variables, and we are talking about a normal distribution, and it's cumulative from this z-score 1.645 all the way to positive infinity. So we're going to pick number 2 because it's cumulative. Now the way you do this is you type in the beginning score of what you're working with. So in our case it's 1.645. We have to place the comma, which is located above 7, and then we have to put in the ending value. Now our ending value, this graph goes over to positive infinity. So what we're going to do is we're going to put in a very large number. So I'm going to type in a bunch of 9s. So it goes off to positive infinity. Now, this calculator is defaulted so that the mean is 0 and standard deviation is 1. So you do not have to put anything else except a parenthesis. And when you do this, it will give you the probability. And we're going to round our probability in this to 3 significant digits. Well, if you round this, the 9 becomes 10, 4 becomes 5. So notice the probability of having a temperature from 1.645 up to infinity is 0.05 probability. Now, sometimes you will have to read the problem to see if it asks you to write it in percent. The majority of the time it will say find the probability, so you'll leave it as a decimal. So that is how to work with a standard normal. Now, if you scroll down, you can see this handout also tells you how to draw the graphs, which we're not going to use that a lot, but I put that on there in case you wanted to. Here's another example. Assume the readings on the thermometers are normally distributed with a mean of 0, standard deviation is 1. That's very important because that tells us it's a standard normal. They ask you to find the indicated probability where z is less than 1.645. Notice we mark off 1.645. Now remember, this is 0. So 1.645 is to the right of 0. And it says shade to the left because it's less than. So if you think about our boundaries, it's going from a negative infinity up to 1.645. So we're going to call our calculator up. We'll do second and vars. normal CDF, but the difference is now the beginning of this starts over at a negative infinity, so I'm going to put a negative and then several nines. Very small number, comma 1.645, and close it up and push enter. Now notice if you round this, it's 0.95. Now if you think about the graph that we had a few minutes ago from 1.645 to the right, and this one is 1.64 to the left, the area is 0.95. The area here was 0.5. If you add those up, notice the area under the curve would be 1. So all the area underneath this, so if you think of about it being a percent, 100% of the graph. So you can check yourself to see, since this went to the left and the other one went to the right, it should add up to 1. So that's an example of the standard normal. Now, what I want to do is go back to your course, and under Calculator Instruction, Unit 3, I want to pick the one that says a normal distribution. How to use a calculator for a normal distribution. Now, I want to scroll down to the example that they give us. Now, I'm going to do this a little different than what they're showing you. I want to use what we've been doing for the standard normal. Now we're going to deal with a normal distribution. Notice the problem. Given a normal distribution, which that's what the other one was, but the difference is this, for which the mean is 70 and the standard deviation is 4.5. This is a more realistic problem because a lot of times we're not going to have a mean of 0 and standard deviation of 1. So this particular problem, the mean is 70, standard deviation is 4.5. We still have to think about the graph. It's still a bell-shaped curve, but instead the middle is going to be a 70. So let me call up the calculator and I'll show you how to use this. We are still going to use second and vars normal CDF number 2, and we're still going to put in our boundaries. Now notice this one that we have, they ask you, it's a standard just a normal distribution, means 70, standard deviation is 4.5. Find the probability the values between 65 and 80. So now what happens is we have a bell-shaped curve and the middle is going to be shaded between 65 and 80. So that's going to be our boundaries. So that's what we're going to type into our calculator, 65, 80. But here's the difference. If you're dealing with a normal distribution that has a different mean besides 0, you have to put a comma on the end and type in 70, which is our mean, comma your standard deviation, which in this case is 4.5. And if you close it up, it will show you the probability of being between these two numbers. So in our case, the probability would be 0.8536. Okay, 0.8536. If it says write it as a percent, notice that's how this handout, this is from a website. Notice they wrote it as a percent. But you remember, if it just says find probability, you'll put in 0.8536. The next thing I want you to think about is it says the probability that a value is greater than or equal to 75. So we're going to do the same problem, second vars, normal CDF number 2, but we're going to have different boundaries. The probability is greater than 75 means from 75 up to infinity. Now I am not going to use what they use. I'm going to use what we did in the standard normal. I'm going to put a bunch of 9s because that goes off towards positive infinity. And then I'm going to put in 70, comma, what was my standard deviation? 4.5. So notice the difference in this. You still put your two boundaries, your lower bound, your upper bound, your mean, and your standard deviation. Push enter, and notice our probability is 0.1333. And if I scroll down, 0.13. See, they wrote it as a percent, but we're going to write our probability as 0.1333. Okay, you'll have to look at your problem to see where they want you to round. Okay, the next part. The probability that a value is less than 62. That means that the shading is on the left of 62. So it's from negative infinity up to 62. So second vars, normal CDF number 2, we're going to put in a negative 9999999, comma, 62. But you've got to remember to put in the mean, which is 70, and the standard deviation in our case is 4.5. Close it up, push enter, and notice the probability is 0.0377. If we scroll down, now notice they convert it to a percent, but our probability is 0.0377. Okay, now the last thing I want to show you, and this is important because a lot of people miss this. What they're going to do is they're doing reverse in this of what we've been working with. They're going to give you the area, the shaded area first, and ask you to actually find the z-score. Now notice they ask you to find the 90th percentile of this distribution, which means shading from the left to the right underneath the curve is 90% of my values. They want to know what would be the score for that. So if you notice, in dealing with the 90th percentile, we use a different value. We're doing the inverse norm. Let me pull this up for just a second. Here is a chart, and this will give you an example. I don't have a graph with me, so I'm just going to use this. What they're wanting you to do, now this particular problem was a normal distribution, but I'm just going to explain. What happens is from the beginning of the graph to the middle, that's 50% of my values. From the middle over to the right is another 50%. So if they're asking you to find the 90th percentile, that means going from the beginning over here at negative infinity all the way over until where 90% of my values, 90% of this area would be shaded. Okay, so we're going to come back down to the problem. We are going to use what we call the inverse norm. We're going from the shaded area to a score. And the way we do this, if you call up your calculator, do second vars, you can find inverse norm number 3. Now, the way you type this in, notice you will have to put in your probability that they give you first. A 90th percentile, you've got to change it to a decimal, is 0.90. We are still dealing with a mean of 70, so we put a 70, and a standard deviation of 4.5. So we close this up and push enter, and what this is telling us is our our actual score, or x value, is 75.8. Okay, now here's what this means. From negative infinity up to 75.8, 90% of that graph would be shaded from those points. So this is an example of using standard normal and normal distributions using the TI calculator.